So what do we have in front of us? In this part, you will investigate geometric patterns formed by squares of side 1 centimeters. Interact with the stage control to see how the perimeter of the shape increases. So at stage 1, the perimeter is 4, and as we know that the perimeter is the sum of all external sides, so all of these lengths are supposed to be of 1 centimeters. Alright, so that's something that we should know by default. Then on stage number 2, we have an entire perimeter of 12, which means that since each and every square is of 1 centimeters, 1 times 3 becomes 3 centimeters, and of course it's going to be 3 centimeters all over the place. And the same thing is happening here again. This length is going to be of 20 centimeters, so each and every length is 5 centimeters. And lastly, since the final perimeter is of 28 centimeters, so each and every length is of 7 centimeters. This is what we know about the 4 stages. For stage, apparently if we have a table like this drawn, so no, not really. Yes, we do. Okay, show that the perimeter of the shape in stage 4 is 28. All right, not too difficult. In stage 4, the shape is a square grid with a side length of 7 centimeters, right? So when if each and every length is of 1 centimeter of one square and there are 7 squares, so I should know that 7 multiplied by 1 multiplied by 4, because there are 4 external sides, so that becomes 28 centimeters. So we had to essentially prove it that this is going to be equivalent to 28 centimeters, and that's how we're going to prove it. All right. Then it says write down the missing values in the table up to row 6. So as we can see, the perimeter is essentially increasing in each and every stage. But to what extent? Here it's increasing by 8, here it's increasing by 8 again, here it's increasing by 8 again. So the next two values are going to be 28 and, sorry, not 28, my bad, um, 36 and 44. And then at the same time it says describe in words two patterns in the table for the perimeter. So one of them is a term to term comparison, that as value of n increases by 1, perimeter increases by 8. That can be one pattern. Another pattern can be that all values of the perimeters are, let's say, you can say there are multiples of 4. Alright, because as we can see, 4 multiplied by 1 gives us an answer of 4, 4 multiplied by 3 gives us an answer of 12, multiplied by 5, 20, multiplied by 7, 28, multiplied by 9, and then multiplied by 11. And you can also add into it that they are multiples of 4 when being multiplied by successive consecutive, let's say, odd numbers, right? So that can also be mentioned. Make sense?
Yeah.
That's great. Write it down and tell me once you're done. Let's move forward then. Um, the next part says, write down in simplest form a general rule for P in terms of n. So the perimeter had the formula, had a sequence 4, 12, 20, 28. So let's write it down. 36. So here we have a difference of positive 8. Here we have a difference of positive 8. So our equation is going to be written in the form of a plus n minus 1 multiplied by the common difference. The principal term is 4, n minus 1 remains as it is, and the difference is of positive 8. So we have 4 plus 8n minus 8. 8n, 4 minus 8 can be written as minus 4. So our answer is 8n minus 4. So that's simple. Oh, what was this? Simple progression being showed. And let's move forward. Then it says verify your general rule for P. So how can we verify it? We can take any three values, right? So let me take the values of 1, 3, and 5. N equals to 1, n equals to 3, and n equals to 5. So 8n minus 4, that can be written as 8 minus 4, which becomes 4. 8 times 3 minus 4 gives us an answer of 20. And 8 times 5 minus 4 gives me an answer of 36. Alright. So when we input these values, we get our desired answer. So hence, after writing this, I can say values are same as in the table, hence verified. This is something very important to write. Write this down and tell me once you're done.
I wrote this down.
Alright, that's good. Then it says based on the previous geometric shape, another shape is also formed from squares of side 1 centimeters. You're going to investigate the area of the shape formed in each stage, interact with the stage to control to see how the area of the shape increases. Okay. So stage 1 we have an area of 5 centimeters square, stage 2 is 13 centimeters square. Alright. Stage 13, 5, 13, 29. I think this is a geometric progression at this point. Show that the area of the shape in stage 4 is 53. Hmm. All right. So what was the area? What is the length of one side? So if the area of this is 5 and there are 5 um, squares in it, I suppose the area of each one is supposed to be 1 centimeter squared, right? So talking about this shape in stage 4, let's have a look. So looking at this, we can see that this has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7 multiplied by 7 is essentially 49 centimeters squared. But what about the external squares present on each side? 1, 2, 3, and 4. So if we were to add 4 centimeters square of an area to it, that gives us an answer of 53 centimeters square. Hence we've proven how the answer of 53 centimeters square is essentially correct. This is one of the few basic things. So, okay, 7 part G. Investigate the values in the table to find a relationship for the area in terms of N. So we can see clearly, first things first, we have to predict these values. So, alright, this is the difference of positive 8. Then there is a difference of positive 16. Then there is a difference of positive 24. Then here should be a difference of 32. And here should be a difference of 40. So 53 plus 32 gives me an answer of 85. And 85 plus 40 gives me an answer of 125. One big hint to understand whether if it's a geometric or quadratic sequence, well, first things first is very easy. But you see, if there is less amount of work to be done, it means that it's a quadratic sequence, because quadratic sequence needs some time to be, completely understood. So not that much amount of work was supposed to be done, so that was a quadratic sequence. And then we can find the common difference is of positive 8, so on and so forth. All right. Predict more values and record this in the table. Done. Describe in words two patterns in the table for the area of the shape. Can you identify two patterns? What do you think? So we can write this as, for the pattern, the difference between consecutive terms increases by positive 8 each time. Another pattern that can be talked about is let's say that the second difference or the second or the constant difference between each term is positive 8. So that's also done. Write down in simplest form a general rule for a in terms of n. Alright, so whenever a general rule is, it needs to be done for a quadratic sequence, something that students can do is something like this: 5, 13, 29, 53, 85. Here the difference is of positive 8, positive 16, positive 24, positive 32, 8, 8, 8. I know that 2a is equal to 8 and a equals 8 over 2, which gives me an answer of positive 4. First things first. So the principal term, not the principal term, basically the second tier difference is what we've calculated as 8. So of course, in order to find the values in the form of an square plus bn plus c, this is the formula or this is the method that we apply. Then 3a plus b should be equal to 8. And I already know that the value of a is going to be 4. So I can say 3 times 4 plus b equals 8, 12 plus b equals 8, b equals negative 4. Then a plus b plus c equals 5. A is positive 4 plus minus 4 plus c equals 5. 4 minus 4 gives me an answer of simply 0. Alright. So 0 plus c is equal to 5 and c equals to 5. So we have the equation 4n square minus 4n plus 5. That is going to be our sequence formed. In order to test and verify, we can use the values of 1, 3 and 5. So if we substitute the value of n equals to 1, we get 4 into 1 square minus 4 into 1 plus 5, and that is going to give us the answer of 4 into 1 square minus 4 plus 5. Yeah, so the first term is going to be 5. N equals to 3. So 4 multiplied by 3 whole square minus 4 into 3 plus 5. That is going to give me an answer of 36 minus 12, 24, 29. Yeah. And then n equals to 5. I can say 4 multiplied by 5 square minus 4 multiplied by 5 plus 5 equals 4 into 5 square is 100. 100 minus 25 is 75 plus 5 is no. 100 minus 20 is 80. 80 plus 5 is 85. Yeah. So all of the values are essentially matching to what I desire above. So the testing and the verification part is complete. Write this down so that we move to justification. The last part says justify a general rule for A in relation to the squares. Alright. How to justify it? Now look at the stage number and then compare it to the one in the area. In stage number n, the main central grid is basically a square with a side length of 2n minus 1. What do I mean? Let's focus on the part where it talks about length first. Here, the length was 1 centimeters each. Here, the length was 3 centimeters. Here, the length was 5 centimeters. Here, the length was 7 centimeters, 9, and then 11, right? Okay. Let's try to find the equation of, or the sequence of, the length. Let's do it. The difference is of 2. So we have a plus n minus 1 multiplied by the constant difference. 1 as it is plus n minus 1 multiplied by 2. 1 plus 2n minus 2. So what do we have? We have 2n minus 2 plus 1. So that gives us minus 1. We have 2n minus 1 as equation for the length. Do we understand this part?
Yeah.
We do, right? Alright. If I have to find the area of a square, that is essentially the same thing as length multiplied by length, right? Or I can also say L squared, isn't it? So, can I write area being equivalent to 2n minus 1 multiplied by 2n minus 1? And can I get the right answer? Let's have a look. 2n multiplied by 2n gives me the answer of 4n squared. 2n multiplied by negative 1 gives me negative 2n. Negative 1 multiplied by 2n gives me negative 2n. And minus 1 multiplied by minus 1 gives me positive 1. So we have 4n squared minus 4n plus 1. But here comes the question. Our equation for the area was 4n squared minus 4n plus 5. How did we get 1? This is the question that you have. So think about it this way. When we move down to the last few parts, have a look. Don't we have 4 additional squares at the end of the entire shape?
Yeah.
So essentially, in all stages, there are 4 additional squares present that are attached to the 4 outer sides, right? So when that adds up to 4 more squares, we get a total of 4n squared minus 4n plus 5. I hope that makes complete sense. You can write all of this down.